Geometry Standard 8. Today we're going to look at Learning Target 2, and Learning Target 2 states that you can establish facts about any triangle's exterior angles. So Learning Target 1, we looked at interior angles. Now we're going to look at the exterior angles that can be made off a triangle. So to start with, we're going to do some vocabulary words. So the first vocabulary word, of course, is an exterior angle. And an exterior angle is an angle formed outside a polygon, in this case a triangle, by one side and the extension of an adjacent side. So mathematically that looks like, so here's our triangle. This is the side they're talking about. And then they extend, which means to further outdraw one of the sides. And that red angle here that we're looking at signifies that that is our exterior angle. So our exterior angle, again, is formed by a side and then an extension, an adjacent side that extends all the way out, and that is called an exterior angle, an angle on the outside of the triangle. Another definition, which is, I'm sure, a review for you, is a supplementary angle. And I always remember supplementary angle because it starts with S, and supplementary and S because the definition is two angles that add up to 180 degrees. So we have two angles. So we have angle, we'll say that's angle A, and this is angle B. And those two angles add up to make 180 degrees. And the reason I started out with supplementary with an S, well, straight line starts with an S, and those two angles that we're talking about make those straight lines. So again, it's two angles that add up to 180 degrees. The theorem we're going to look at is called the exterior angle theorem, and the theorem states that an exterior angle of a triangle is equal to the sum of their two opposite interior angles. So let's break that down. So this exterior angle, so here's our side, here's our extension. This is the exterior angle that we're looking at. And that exterior angle is equal to, so this 100 degrees is equal to the sum, so remember that means addition, of two opposite interior angles. So exterior angle is equal to the opposite, so this is not, so what we're talking about is not that angle. It's not the one that's attached to the interior angle. It's the ones that are opposite. So in this case, it's 60 and 40. When you add those two up, the sum of these two are equal to the exterior angle. So let's look at examples. So our first example here is we have a triangle. We have 95. We have an unknown x. Again, we have another unknown over here. We're going to call that y because we're going to solve that in a little bit. And then we have 142 as our exterior angle. So notice that's an exterior angle. It's on the outside of the triangle. Our interior angles are 95, x, and y in this case. I'm going to explain two ways. We're going to start with how you solve for x using the exterior angle theorem. So our exterior angle theorem, just write that down so we can remember our two ways, states again that if the two sums of the interior angles that are opposite of the exterior angle are equivalent to each other or equal to each other. So I'm going to write down 95 degrees plus x, our unknown degrees, equals 142 degrees. So I know we're starting out simple, but I still want you to write it as an equation so you get used to solving in an equation format. So since our unknown is x, we're going to subtract 95 from both sides, or 95 degrees, I should say. And we learn that the x is equal to, when we subtract that, throw in our calculator, doing our head quick, it's 47 degrees. So we just learned that this angle, this interior angle right here, is 47 degrees. And we can quickly mathematically check if we take 95 degrees plus 47 degrees. So remember the opposite interior angles, so 95 and 47 equals this outside or exterior angle of 142. degrees, and that is correct, so I know mathematically is correct. Now, the other way to do this, and I'm going to, we'll change this one, is we're going to solve it using the idea of the supplementary. Now, the supplementary one in this case takes a little bit more work to get to x, because we're going to first have to find the value of y to help us with getting the value of x. We know already it's 47, but we're just going to show you another way to do this. So we're going to use that idea supplementary. So we're going to use that exterior angle of 142. And you notice that the angle y and the angle of 142 are going to equal 180. So I'm going to set that up as a equation. So the y angle plus the 142 exterior angle has to equal 180 degrees. So we're going to solve this algebraically. We take away 142 degrees from both sides, and we find out quickly that y is equivalent to 38 degrees. Now, why does that help us? So we'll put 38 degrees. That helps us because if we pretend that we didn't know that this x value, we'll go back to not knowing, that this x value is 47. So we used our supplementary angles. We found 1 degrees. We'll then go back to learning target 1 and go back to go, oh, 3 interior angles equal the sum of 180 degrees. So if I know the angles already of 95 degrees, the found angle of 38 degrees by doing the supplementary angle idea, then this x that supposedly I don't know, I can use my interior angle sum theorem, and if I add them all up, they have to equal 180 degrees. And then I go ahead and solve like you did in LT1, 95 degrees plus 38 degrees equals 133 degrees plus the unknown equals 180. And then we're just going to solve this algebraically. Subtract 133 degrees from both sides. So x is equal to 47 degrees, which is a good sign that we got them to be the same answer both times. So again, you can solve them using the exterior angle theorem, or if you like the idea of the supplementary angles, you can use either one of those theorems or ideas. So we're going to look at the next example, which is on page 9 in your packet. So if you look at this, we're trying to find what MOP equals. I'm just going to look at the problem here. What does MOP equal? So M down to PO over to P is this angle. So if that helps you to draw an angle out, that would. So since it's opening, remember you go from one side of the angle to the other side of the angle that we're looking for. So I'm looking for that degree. Well, quickly, either I can show you both ways. We'll do the exterior theorem first. If we have these two angles inside that are opposite, so 38 degrees plus 55 degrees, that is equivalent to the exterior angle of 5x plus 3 degrees. So remember, the sum, when you add these two up together, they equal the exterior angle. So we're going to go ahead and solve for h. I'm going to subtract 3 degrees. And so I probably should have added these two first. So 38 plus 55 is 93. So I'll cross those out, make that 93 degrees. And then 93 degrees minus 3 degrees leaves me with 90 degrees. So 5 h's equal 90 degrees. Algebraically, we're going to divide by 5. 90 degrees divided by 5, that is 18 degrees. So 1h is equivalent to 18 degrees. So I'm going to put that over here. H is 18 degrees. Now going back to our equation, M to O to P, which is this angle again, right now is 5h plus 3. But now that we know the unknown h is 18 degrees, we can go ahead and plug that in. So we're going to take 5 times 18, add the 3 degrees, and when we add that all up, we see that this angle is 93 degrees. So again, the answer to this is that the measure of angle MOP is 93 degrees. Okay, let's look at the other way you could solve this. So I'm going to pull this down a little bit so we can still see our angle up there. You can use your supplementary idea. So you could have said 5h plus 3. No, you can't. So we'll just go to the next one. Okay, example number 2. So if you look at this, we have two interior angles that are opposite of the exterior angle. So we can use the exterior theorem, angle theorem. So we know that 62 degrees plus 4n plus 3 degrees has to equal that exterior of 121 degrees. So if we go through the math here, algebraically, we're going to take 62 plus 3, we get 65 degrees, plus 4n still equals 121 degrees. Our exterior angle, we're going to subtract the 65 degrees from both sides, and we get 4n's is equivalent to 56 degrees. Divide by 4, and that would equal 14 degrees. So we know that the n in this problem is 14 degrees. Now we're going to look at what they want, or what we're trying to solve for. So our first one is angle ABC. So A to B to C. So if you think about angles there, that's A to B to C. And that angle is right here. So that angle is named 4n plus 3. So we're going to find the value of that. So since we just found out that 14 is n, we're going to plug that in. So 14 times 4 plus the 3 degrees that are already there. And we do our math. Throw it in your calculator if you need to. And we find out that is 59 degrees. So this one's 59. We'll write that here. And then we're going to go back to the problem because they have asked one more question. And the next question they ask us is, what is the measurement of ACB? So now we're going to go back to A to C to B. Okay, now I'm going to give you a little hint. That middle angle will at least tell you the vertex. And remember, the vertex, when you draw an angle like this, the vertex is the point where the two sides meet. And that vertex, at least that middle number, will tell you what vertex. In this case, we're looking at C, but there's two angles on C, so you got to be careful of which angle that you're looking at. So in this case, we're looking at the one that I outlined in blue, so this one. So you have two ways. You can solve it using your supplementary angle. So since the angle on the other side, the exterior angle is 121, we can say this now unknown, we'll call it x. So x plus 121 degrees has to equal 180 degrees because these two angles together from here all the way over there is 180 degrees because they form a straight line, hence the reason why they're supplementary angles. And you can go ahead and solve by taking 121 from both sides, and x is equivalent to 59 degrees. So they end up being the same degrees, notice. Okay, we're going to double check that by doing another strategy. So let's say you didn't see the supplementary angles. You know, since this one up here that we found was 59 degrees, you know your interior angle theorem that you learned from last learning target, that these three angles have to add up to 180 degrees. We'll just throw it over here. So 62 plus, we just found out that was 59 over here from the previous problem. We're pretending we don't know this degree here. So we'll put that x has to equal 180 degrees. So quickly, we're going to do some algebra. So 62 plus 59 is 121 degrees. Plus x has to equal 180. Then you're going to subtract the 121, and you're going to get the same answer we got before, which is 59 degrees. Now, what I would suggest, once you figure that out, is just quickly type in your calculator. Just make sure one more time that's equal to 180 degrees. So 62 plus 59 plus 59. I quickly put it in my calculator and I notice it equals 180 degrees. So I know I'm correct.